Hi, this is Wes Simpson with another edition of the Summer Sessions on Media over IP, brought to you by Ames and the VSF. With me today are Felix Poulin, Director of Architecture Lab at CBC Radio Canada, and Willem Vermost, Design and Engineering Manager of VRT Belgium. These gentlemen are joining me today to talk about the 2020 EBU Pyramid of User Requirements. Welcome, Willem and Felix.
Hello, Wes.
Hey, hello, Wes. You find yourself a good spot, it seems.
Yeah, I don't have a lake like you do. That looks pretty nice. So let's get started.
All right. So let me kick off quickly. We have today for you the 2020 EBU Pyramid of User Requirements. And before we really get into the topic, we would like to take a trip back in memory lane about some new buildings throughout Europe and also in Canada. On the left top, you see BBC in Wales, Cardiff. Wales, Cardiff is live as we speak. On the right top, you see our friends Felix in Montreal. The left bottom, that's TPC in Switzerland, and the right bottom, that will be built in the far future. That's the VRT building in Belgium. Now, all of these buildings, well, they have one thing in common, of course. Well, they had a predecessor. And the predecessors of those buildings, they were built in the early 60s and 70s. So financially, those have been written off and those start to cost too much. So just for your information, at the back of this slide deck, you see the face or the facade of the building in Brussels. If you ever visit, you pass by, please take some distance, because those nice elements, those decorative elements do have the tendency to fall off the building. So it's time we need to refurbish it. So let's take a look at the map we've been making. So at the back of this map, you'll see a typical technology curve. Now we try to depict a few of the projects we saw throughout Europe. Back in 2014, you see some of the gray boxes here on the chart. The gray boxes represent proof of concepts. Of course, BBC with their Violet project, they were one of the first to conduct a project with IP-based studios. You see the Commonwealth games, the Wales proof of concept, the VRT EBU live IP proof of concept, which was a very well-known one. RTS, and so on. They all conducted proof of concepts. Now, of course, those proof of concepts were conducted to know one thing. Should we remain with SDI or should we go IP? Now, if you build a new building, you'd better be building one without legacy, right? So all these buildings you see here on the map, those have or will be having IP in their facility. There's RTL City, that was one of the first with 2022-6 to go live in Luxembourg. And on the way, you have projects that will be coming up with 2110. Now, there are three major projects in the middle: BBC Cardiff, SRF Zurich, and CBC in Montreal. Now, these are just the projects that I know more or less the date. Now, there are another bunch of projects coming up. I don't have the date yet. You see them on the right-hand side of the screen here. Now, three major buildings have been as good as finished. BBC Cardiff is live, SRF in Zurich is live, and CBC Montreal, well, I guess Felix can tell more about it. It will be live pretty soon. So, if we look back into time a little bit and we go 2 years back, that's not as far, right? It's just 2 years back in time. There was the Network Technology Seminar at EBU, and we invited a few of those guests to talk about their new buildings. So the first presenter we had, that's Thomas Edwards. Thomas Edwards, he opened the whole seminar. And well, I should say he's from Fox at that time. Now he's the VP Engineering and Development at Walt Disney Television. He gave us an interesting presentation. IP, the promise, the progress, and the path to perfection. Well, he's always a very positive guy. But then he asked one big major question. Where are the full stack systems? Now, we went through the presentation a little bit, and Thomas explained this. Well, if you plug a device, it even doesn't get an IP address, so you should have DHCP. And if you plug it, how does it register or does it find another equipment on the network? Or how does it connect to something else, or LLDP? How do we control all these things? Where is it? So, full stack systems. So as a next presenter, we thought, well, Mark Patrick, please explain what you have been doing at BBC Wales, the Cardiff Central Square project. And Mark Patrick, well, more or less, he would state the same issue. He says, well, we need to see a confident leap from the R&D lab to available products. The delayed implementation of a common control standard is holding up the widespread of adoption of 2110 products. Well, that's interesting to hear, Mark. So let's go to Felix Poulin, well, also later on live in this cast, but maybe during his presentation, Felix gave an update on the new Maison de Radio Canada, and he stated us about the lessons learned thus far. Now, those lessons were, well, quite short, and Felix said, we demand a full stack solution. Well, that's already the third one in a row. So let's ask ourselves what Sandro Furter had to say about the famous Metechno project in Zurich and the full IP future of SRF. Well, Sandro mentioned, well, are you able to share your experience? There are a lot of groups and forums. It's important that we share all the experiences that we're going through and share it openly with each other in order to move in a much faster way. Well, that's a lot of stuff. So I dare to say that first installations did suffer a lot. But on the positive side, they provided a lot of learnings. Now we can put a few posters on the wall here. Newsflash. Vendors created their own proprietary control layer. Well, it looks nice, but it's a major vendor lock-in. We're not capable of building something multi-vendor. That's quite strange. Another example, hey, we need to configure all 500,000 multicast addresses manually. Well, that's not nice. Or January 2009, I did mention it was a trip back into memory lane, right? Thank you for your email with the SDP file. An email, are you serious? SDP should go over the network and that sort of things. Now, with users, it's always pretty easy to complain, right? We're not making something, we can just say, hey, we bought it, it should just work. Now, with EBU, we came together and we said, well, what can we do with all these complaints? And maybe we can turn this into something positive for the whole industry to move forward. So this is why we started to think about something that, again, our colleagues from Canada came up with the idea. And that's what we started calling a pyramid. So back in 2018, we drafted the first pyramid, and we'll give you a short overview here and the tip of the pyramid. It's what we call the media transport. And the tip, well, that's actually green. We'll discuss later on why we say this is a green part. Now, there are a few layers. The pyramid is much bigger than just a media transport. In order to have a working system, you also need to have timing and synchronization. You also need to have discovery and registration, and you need to be able to configure and monitor all those elements in your facility. Now, moving to IP means that you're more prone to security issues. So security, that's a big challenge to the whole ecosystem here. This is why this is the fundamental layer to the whole system. Now, when we just published this thing, we were very happy to see that as well NABA, as well as the WBU, also endorsed the pyramid. So, of course, we're 2 years later, and really a lot has changed down the way. So now I would say, let's bring on the red curtains, and please do have a drum roll. And let's bring in Felix to talk about the new version of our EBU pyramid.
Thanks, Willem. So I don't know if you've seen the difference there. Some are obvious, the colors. and some are more in the fine details of the text. We will run through that during the rest of that presentation. This revision was really driven by the experience of those first major projects that shared their knowledge and shared their experience, tried to be more clear about their requirements. So we add some to the pyramid. We change some recommendation that we're using the word should into some mandatory requirements. So we use the word shall for them. And we even relax some requirements as we realized they were not necessary and it was not useful to be too demanding for those requirements. So we will go through these different changes. Color-wise, you see on that version more green on the pyramid, and it shows that there's a growing maturity of the whole industry, the whole ecosystem. We could witness that in the latest trade show and the JTNM events. More devices are implementing, for example, the layer 3 operational control that was named previously the discovery and registration. We'll see why we changed the name of that layer. And also configuration monitoring was fully red, now has a little bit of yellow in it. So it really shows that there's an improvement over time. If I go to the general principles of the document, so these applies to all the layers. First of all is what's important is that we follow cybersecurity best practice in everything we do, in every layer of the technology. We also seek for implementation in software and standard IT equipment as much as possible. This really is the enabler to a more flexible facility that we're really trying to achieve by this transition. And leverage and reuse IT and internet standards as much as possible. We don't want to reinvent the wheel when there's already something in place that exists and that we can reuse. The benefit of reusing internet standards is that there's a lot of tools, there's a lot of knowledge in the industry already to help. A new addition to this document is a clear definition of open standards and specification. We use a lot the word open standard and specification throughout the document. The document includes a useful definition. So it has to do with the documentation. An open standard specification is adequately publicly accessible, actively maintained with the latest version, and free to obtain documentation. That's very important. So that way we can integrate those standards and we can understand them more easily. A clear licensing policy, a fair, reasonable, non-discriminatory, preferably royalty-free, but at least that it's clear what it will be costing and the licensing policy, and a notion of backward compatibility also is penciled in. We see that there's a range of degrees of openness. We want to be very open about this notion, but we know that on the one hand you have proprietary closed solutions and methods. Sometimes you need an NDA. Sometimes you need to. It's kind of buried in the product. You don't have access to the documentation. But sometimes it's proprietary, but it's openly documented, and it's already better in terms of providing this openness of integration. Yes, it's a company that is in charge and will make decisions about the future of the evolution of the standard, but at least the documentation is there to dig into it. And as we go, we have standards that are produced by standards body and organization that provide a clear process, a clear and transparent process. Some comes with a fee. You need to buy the standard document. And sometimes even better, the documents are for free. And why it's useful and important, and the whole IETF word, for instance, is built using that approach, is that when you're a bigger company, maybe there's no big deal to buy a suite of standards to be able to do your work. But if you're a small company doing software tools, software components, it can be a problem if you have to buy 10 or 15 standards. And if you work in a community, in an open source community, and you want to have a number of developers, independent developers having access to the information, that can become a barrier for adoption. And that's why also when there's a free open source, let's say, for example, a reference implementation that people can reuse or look at how it's coded, that's also a good way to standardize things. So there's a whole spectrum of levels or degrees of openness, but at least we want to meet the minimum that is publicly documented. On the transport, I hand over to you, Willem, to talk about this layer.
Oh, thank you, Felix. Well, with completely open source, for a moment I thought you were going to plug EBU list. Sorry. Anyway, now media transport, the tip of the pyramid. Well, it's green. It was green on the first delivery of the pyramid as well. It talks about single link video with -20. Now, those are specific words, single link video, because we do have people that came to us and said, well, they're talking about a standard with multiple links for one video lane. It will introduce multiple points of failure. So we thought, okay, we'll take this complaint or this requirement seriously. This is why we put specifically single link video. Now, the second part, software friendly, this probably needs to have some more explanation as well. A few years ago, when I started working at EBU, I was a colleague of Felix. And at that moment in time, we started drafting the roadmap for IP. You probably remember the roadmap. It had 2022-6, then it had the elementary flows on top, and so on. Now, on the right top-hand side, there was a green patch, and the green patch says, well, this is clearly where we need to go. This is the end goal to move to IP. We need to have flexibility, scalability, but shareability as well. It is only with software that we can move into things like the cloud and scale up, scale down, or share CPU resources between different processes, or change over time into different processes on the same CPU or GPUs. So software friendliness, that's a big and important thing for everyone diving into 2110. There are some other things as well, and this is really new. So universal multi-channel and low latency audio, this was on the map already, but we degraded ourselves a little bit. We said, well, instead of level C, level B is enough. Felix, can you explain a little bit from your experience why we got back to level B here?
Yeah, so just reminding that the goal of the pyramid is to provide a set of minimum user requirements. And what we realize in the different project that we are implementing at the moment is that the way we use audio flows is by grouping or bundling audio channels that are phase related. So an audio pair, we will use usually a one flow of 2 channel, a 5.1 program, we will use a 6-channel flow. So an 8-channel possibility of the level B, sometimes using 125 microseconds packet time for the low latency applications, it's sufficient in most of our use case. And even when we have to carry a lot of the audio channel together, let's say a snake between a stage box and an audio console, we prefer to cut down into multiple flows of 8 channel rather than a big flow of, let's say, 64 channels. So you'll still need level C for some specific application, for some point-to-point application. But when you want to stay universal, more compatible with the maximum number of devices, level B is a good target.
Well, then I have some good news for you, Felix, because when we dive into the results from JTNM tested, you'll see that most of the devices or the things that are on the market today have no problem at all with level B. So I think this is probably a very good step forward for the pyramid as well and for all the users. Now, the fourth thing we find in this layer is, of course, stream protection with 2022-7. So the next layer, that would be timing and synchronization. There's already a little bit more green here, so that's the positive part. And what do we ask? That's Ptp version 2 configurability with both profiles. So not a fixed parameter set, but the ability to configure the Ptp profiles or all the parameters overlapping between the SMPTE and the IIS profile in order to make it really work together. Multi-interface Ptp redundancy, well, that's an interesting one. If you have -7 for redundancy, you have 2 interfaces connected to your network. So where do you take the Ptp? Who's the master side? That's really important. Now there are a few new things, and really important as well. You know that when you connect your device, it's probably locked to Ptp. If you don't see anything happening with the video, you think it's locked to Ptp. Now, all the know-how, if it's really locked, is within the box. So the thing that users really ask us is, well, can you not provide something to get the result out of the box, to really know and monitoring that the device is really locked? And lucky for us, there are some standards or RFCs already out in the open that you just can use and that could be implemented in order to do this. Another important part is, well, can you lose Ptp up for 5 minutes and then reconnect to Ptp without any glitch? That's a very important one. Now, the last one, probably, I'll ask Felix again to go in depth about synchronization of audio, video, and data essences. Because when we do have elementary streams, well, of course, they should be in sync. So this is a really key issue here. Felix.
Yeah, and remember when we decided to take the approach of elementary stream in SMPTE 2110, there was a promise that there will be a way to deal with the timing of the different stream and to keep the synchronization between them. On the next slide, you'll see that it's essential in a big system to manage lip sync and other inter-essence synchronization. This is necessary to achieve the goal of dynamic and agile systems, to be able to change a system and easily retime that system according to the changes. The hope is the SMPTE 2110-10 is under revision, and there's good discussion about how to solve that problem by propagating the sampling time throughout the production chain, and so that the receiver somewhere down the chain can use those RTP timestamps to realign the different flows together. So that's very important, because so far it's really a gap in the system, and so far we had to use the good old way we were using in SDI, is to include line delays in the system and to manually measure and tune those delays, but that would not work for a more dynamic system that we're trying to achieve. I'll continue with the next layer, operational control, because it's important to realize that now we talk about the tip of the pyramid, the transport, the time and sync, and these are obvious for what we do with media. But without the bottom of the pyramid, there's no way to build a real operational, maintainable, manageable system. So the rest of the pyramid is as essential as the tip of the pyramid for a mature system. For operational control, we've seen a good maturation, a good adoption of the different elements on this. Of course, all the question of discovery and registration, connection management, and audio channel mapping using AMWA and Nmos suite of specification. And I'll explain a bit more how this works. On the device control side, that's a new addition to the pyramid. And we'll go into details also. The LLDP, so that's a link layer discovery protocol that is useful to inform the network controller about where is that device connected and physically in the network, on what switch, on what port of that switch. And it informed the controller to establish the proper routes in the systems. So just to explain in a very briefly, and I know that in this summer series there are a number of presentations that go more deeply in the topic of Nmos. So I just want to explain why Nmos is necessary in a large system. If we think about as simple as the routing, we have a source, we have a destination, a camera, a display. Here we have a small router, a small matrix, and a control panel. And the connection of that source to that destination is as simple as punching a source and a destination on the panel, and everything audio, video, ancillary data being embedded in the SDI, the signal flows and you get the image on the display. Now, the next one, we do the same, but in the 2110 world, 2110 alone without control protocols. First of all, you have multiple flows usually. So in the case of a camera, you could have video, a number of audios, ancillary data. All of these flows needs to be configured, provided in a multicast IP address. And then when it's time to establish a connection, you need to talk to the receiver and tell the receiver to join each of these flows separately. And if you imagine the scale of a larger system, the number of manual operations that are required to establish connections, it becomes very tedious. We've experienced that in the lab just using a waveform monitor, being able to monitor the flows. And each time you have to type in all those different multicast address in your tool, you multiply the time it takes to set up everything. So on the next slide, I show...
Hold on, Felix, sorry. Okay, just so we'll go to this slide and just start with this slide. So on this slide,
what we see is how the same applies, or the same operation of connecting, but using Nmos. So first of all the devices on the network will register themselves in a registry using the ISO4 discovery and registration specification. In addition to that, there's the AMWA BCP002 that explain how to indicate in the registry when flows are intended to be used together. All the different audio, video, and ancillary data from that camera can be said being named by the same tag, the same name, and therefore the controller, when it's time to make a connection, can use that information to do a bulk connection of all the flows together. Using ISO 5, talking to the receiving device will establish connection. It will provide the multicast addresses. It will provide the SDP file that contains all the format information, so the receiving device can really tune that flow properly. And then ISO 8, when it's necessary to reorganize the audio channel in different way, if you have to, for example, swap different channels. So Nmos is very important, even in a larger system, because you want to have this minimal control plane to be able to basically redo what we were used to do with SDI, but now with 2110. And the other addition to this layer is the device control. The reason why it was not there previously is this is a domain where there's not a widespread, uniform, common protocol across all the industry. So what the pyramid is saying now is that we want an open method for device control. An open method, again, can be a number of things, can be an open standard, can be a proprietary method, but that is well documented and that fill the requirements for open definition. And be aware also that there's an ongoing activity in the AMWA, in the Nmos, on the Nmos device control modeling that is also thinking about this problem. The one that the document recommend when it's time to use events and tally control, so that's a sub part of that device control domain, is ISO 7 from the AMWA. The next layer is about configuration and monitoring. So a small addition to the document is the recommendation to use ISO 9. ISO 9 is a new specification that was published lately, and that provides a number of environmental common parameters, like the Ptp parameters that are common across the system. So that's a place, a registry to provide this information across the different devices. On the configuration management, I will talk about it in the next slide, but it's hard to spell, to tell one way of doing it. But the key thing is that every device should provide one way to be configurable programmatically. There's different ways to do that. Yang, open config, either providing an open API with documentation. Sometimes even an SSH access is enough. And the same applies to monitoring protocols. It's important that the device is monitorable and provide a good verbose level of monitoring. And then again, it's hard to tell one way. Even a more traditional SNMP way is already much better than nothing to be able to monitor. The open configuration management, I want to come back to it and say why it's important is it's to enable the automation of provisioning and configuration. And in our project at CBC, we have more than 5,000 endpoint devices. And we have a lot of software and firmware updates for those devices because this is new technology and this is evolving all the time. So we need to be able to do something more automatically, less manually, to deploy it in the first place, but also to maintain it and use it over time. And also that's the door again to agile facilities, because if you can configure your device programmatically, you can have an orchestrator that will change the way your devices are used. There's a full EBU tech document, TR 055, that talks about this wide topic of automation for media facilities.
Now, the bottom layer, this is probably the most horrific layer of them all. And actually, it's not something that you just only can point your finger at vendors. This is something we need to do, all of us together. Security, everybody is part of security. Now, there are a few interesting guidelines, safeguards. That's EBU recommendation 143. And there are some tests described. That's EBU R148. Now, these tests have been run at the JTNM tested event, not to give them a quote or a score, but just to inform vendors how their equipment is doing with regards to security. Sometimes they're surprised. Sometimes they say a big thank you because maybe they don't have all the know-how of really deep security guys. So at VRT we do have a guy that he's called Gerben, and he's a top guy, and he was part of the JTNM tested as well to do all the testing with regards to security. Now, if you think about your facility at the end, and you want to secure it a little bit, then of course you can think about firewalls and that sort of things. But one of the things that will be probably on a separate network, that will be all the high bandwidth video. Now, something that you might want to integrate with the rest of your systems in order to do automation and that sort of stuff, that's probably everything that has to do with all the configuration and management. So this is why it's interesting to know that there's something called AMWA BCP 003. This enables you to secure all the API calls in your facility. And this is good because the whole control plane can be secured with this, just with this specification, which is pretty nice. And this will bring you a whole way into having a more secure facility. Of course, besides being up to date, having the latest software and the latest patches, as well as of your video software, as of the operating system which is running, and all that sort of things. So security, it's a multi-layer thing, and it's just not pointing in one direction. It's all of us who have to work together in order to get it done. Now, if we go back a trip into memory lane, we have these two gentlemen. Felix, do you want to take over again?
Yeah, it was in 2018 NTS that during the whole seminar became clear that we needed to do something about bringing together, building together a whole stack around ST2110, and this triggered the work of the pyramid. But very quickly it became clear also that the industry needed to agree on a profile for professional media. How do we use 2110 with Nmos with all the different standards together? Those standards are of many options, many different possibilities. So this is where a group of cross-industry volunteers started to draft the work. And this led to the JTNM TR 1001-1. The JTNM TR 1001-1 is a system, environment, and device behavior for 2110 media nodes in engineer networks, and it covers networks, registration, connection management. This came as an answer really to the request from the user with the pyramid. And if you look at the pyramid again, you will see that TR 1001-1 covers a good number of items from the pyramid. And that's good to see. And a number of devices on the market are implementing TR 1001-1. So it's a good news in terms of adoption. It's also provide an indication that there's still a number of things that the industry has not widely adopted. And these are the rest of those components that are not highlighted on this pyramid. So you can see the pyramid really like a a demand from a large group of users, but also as a direction for the industry as to what's important to develop and implement. And the good news is almost a year ago at the IBC, AIMS communicated that the TR 1001-1 was added to the roadmap. So there's really a large coalition of the industry that is supporting this implementation. So we're already at the end. We can conclude with a few major points. First of all is that the user actualized their clear requirements for a full pyramid of technology. That's really an opportunity for the industry to see where they should put their effort. We've seen a very good growth of maturity of product over the last 2 years. It's really clear that the whole industry is on board and is investing to develop the technology and to get it to its full maturity. We've seen that in the different JTNM tested events results. And we cannot stress more the importance for the customers to demand the full pyramid. Don't hesitate to ask for all the features in the pyramid, because that's really a direction of what the user wants.
So Felix, maybe just to add on here, at the bottom of this page, you see the link. And as my dear colleague Yevgen would say, don't delay, download today. There's the https tech.ebu.ch/pyramid, and you have the latest document just for free. What do you want more?
Well, thank you, gentlemen. That was quite a presentation. Just probing a little bit deeper, we've seen a lot of people making, improvements to their equipment, implementing new things on the pyramid. What's your experience? How much of a battle has it been getting people to, really adhere to the terms in the pyramid? And do you think it's getting easier, or how is it progressing in the industry?
I would say it's really it's like a chicken and egg situation all the time. There's always a tension between the demand a single user will do and the priorities that the vendors has to put in their backlog in order to deliver products. But by providing a tool like the pyramid and by including these kind of requirements in our tender, in our RFP, in our discussion with the vendors, I think it really helps to mutually educate each other. We can express better what we need, what we want to the vendors. We can understand also what's their priority and their limitation, because obviously not everything can happen in one day. So there's certainly a tension, but I guess by providing a clear explanation of what we need, I think it helped a lot accelerate in the right direction, and we've seen the results over the last 2 years in our projects. All the products are getting more mature every month. So it's a question of time, and it's a question of being clear with what we want to do.
No. There's one interesting thing. There are proprietary solutions that say, oh, we have it all. But there's just one caveat to this. People just don't want to stick with one vendor. They want to plug the best boxes they know together to bring their system to life. And of course, with open systems and open mentality, it takes a little bit longer. But when it gets there, like we see right now, it's getting to be a very powerful system once you get it all together. Now, I was so lucky to be part of the JTNM tested over the last years. And you could see the change of all the participants being more prepared to come to know what we were looking for, how to get it tested, and the results are there as well. You can see this in the sheet that you can download. So I'm actually pretty positive how it has been going. And to be honest, it's just over the last 2 years. This change is probably the biggest change in the broadcast industry over the last 30 years. And it's not just telephony bringing to IP, because telephony is just dialing a number and making a connection. We need to do more. We need to make the connection. We need to know what type of device it is. It's not just a phone. It could be a camera, a microphone, a vision mixer, all those sort of things. So our world is much more complex, and we succeeded in, let's say, 3 years to come to a very mature level already. Of course, there's always room for improvement, but I'm sure that we're going in the right direction.
So both you gentlemen have had, fairly distinguished careers at the EBU, but now both of you are back at what could be termed your home broadcaster. How has that change been for you, and what do you see? Has your perspective changed at all, being not in Geneva but back in Brussels or Montreal based? How has that changed your perspective on things?
First of all, for me, it was going back to apply what I was working on at the standardization level for I would say the genesis of all this whole media over IP transition and discussion, and go back to a broadcaster with a real project, having to make it work, having also to assume and to certain level of responsibility of delivering results. But that's very interesting, because now you can see a real big system taking shape. And yeah, Geneva to Montreal. Yeah, I miss the lake and the mountains and the mild summer. But Montreal is a cool place to live. So I'm very happy to be back home as well.
How about you, Willem?
Well, never say never. I know I'm in Belgium now, so we supposed to have our new building within the next year, but something came in between, so I think we have to postpone till 2026. But meanwhile, getting back, I discovered that the last 4 to 5 years, we've taken a giant leap into the know-how about these systems, and I think probably the time we have left now for the new building we could use to educate and to get people up to speed, because that's really a giant leap from the current know-how to what you really need for new systems to be built. So I'm taking full advantage of all the know-how we've built up, and well, knowing all of you as well, in order to get this done at VRT.
Well, gentlemen, thank you very much for your time today. Very interesting presentation, and I hope the new edition of the Pyramid becomes as well embraced as the industry as the previous ones. I'm sure it will, but it's good to see it changing and evolving and pushing for more green. That's a really good thing.
Thank you.
Okay, thank you, Wes.
I mean, Geneva is such a beautiful place, but I'm sure it's nice to be back home for both of you.
It has its pros and it has its cons. But to be honest, the biggest change is now you see that there's more to life. Mm-hmm. If you never traveled around, you're married to your church bell tower.
Yep.
But when you travel a little bit, then there's more to the world than just your bell tower.